Hello YouTube, this is going to be a continuation of the Linux from scratch run through that I'm doing. And we are on chapter 6 and we are cross-compiling the temporary tools. In the last chapter we set up we compiled a cross-toolchain and we got up to here after some messing about, mainly with me not reading the instructions. I think this is going to be quite a long video. There's a lot of things to compile here, and we have to compile GCC and Binutils again, and I remember that took a while last time. So without further ado, let's continue on. And what we're going to do is going to read the introduction first. This chapter, it says, introduction, this chapter shows us how to cross-compile basic utilities using just built cross-toolchain. Right, so that's the toolchain that we just built in the last video. These utilities are installed into their final location but cannot be used yet. Basic tasks still rely on host tools. Nevertheless, the installed libraries are used when linking. Okay, so we're basically whenever you're compiling anything with C or C++, there's a linking step, and basically it's linking to the newer tools when you compile in the in our LFS installation. Using the utilities will be possible next chapter after entering the shoot environment. I have no idea if that's the way you're supposed to say it. I've heard people say it different ways, but I say shoot. I suppose it just means change root. But all the packages built in the present chapter need to be built before we do that. Therefore, we cannot be an independent of the host system yet. Once again, let's recall that improper settings of the LFS together with building as root may render your computer unusable. This whole chapter must be done as a user LFS. Well, if I do who am I? I'm the LFS user still. That's good. With the environment as described in setting up your environment. Well, I save the machine state every time I finish the video. So it is as if I'm doing it in one step, essentially. So what we want to do is we're going to compile something called M4. I don't actually know what that is. There's a macro processor. Okay, so I think we need to CD back into here. We'll just clear that. And I think, what was we compiling before? Let's have a quick look. It was GCC. I think we're supposed to remove the sources. Right. If you remember from the previous chapter, so all the sources must be in LFS sources. And this is the bit I read and then I didn't fully understand. Change to the, so basically every time you build, you have to basically do this. Change to the LFS mount, change to the mount LFS sources directory, which is where we are. For each package using the tar program, extract the package to be built. So basically it's tar xf. You don't use any of these other tools, just ignore that. Change the directory created when the package was extracted. Follow the instructions for building the package. Change back to the source directory when the build is complete. Delete the extracted source directory unless instructed otherwise. I was not instructed otherwise, so I think you should have deleted it. So we'll go back to chapter 6 and we need to tar, I think it's xf. I guess it's M4. And then we do CD M4. And then there's our configure step. We'll just run that. These usually don't take too long. made myself a team before I started because I think it's going to take a while. Right, and then we do make. So we'll just clear the screen again. I'll just make that a little bit bigger. Do make. Right, that was really quick. It didn't take long at all. It was quite nice. And that's completed. So that was pretty straightforward. So what we want to do is cd out of here rm minus rfm4. There we go. And then we are compiling Ncurses. So this be again, it's going to. I expect it's going to be very mechanical. And this is Ncurses. So Ncurses. cd into Ncurses. Right. So what it wants us to do here. But first, run the following commands to build the tick program on the build host. Okay. So we make a build directory. And then we run this script here. So we'll just run that. So what does this do? It's configured awk equals score make c dot include make c progs tick. Okay, so this basically does loops through stuff and compiles it. So we run that. This takes, hopefully won't take too long. Right, and now we do the configure step. And right, so again, there's a bunch of configure options. I won't read these all out. So this goes and basically makes Ncurses build and install C libraries. Right, so this basically tells it not to install the man pages. With normal, this prevents Ncurses from building and installing static C libraries. Okay. Without debug. Right, so these are all fairly self-explanatory. So I'm not going to go through these, even though I've gone through half of them by just having a read. I do like to understand what I'm actually putting into the terminal. So we just copy and paste that in there and wait for it to compile. All right, so that's that done. Sorry, configure, sorry, it's not compiled yet. And now we do make. Now this could take a while, I would imagine. Oh no, that was very quick. And we'll do the install step. So this looks a little bit more complicated. So what does this do? This does your make. Does the make install on these bits and pieces we compiled up here? Okay. Then it does a sim link of the libcurses. So if we do ls in here, I think there's going to be, is there going to be libcurses in here somewhere? And then it does some string replacements on this header file here. So this is a Ncurses H. So it essentially does a I'm not great at reading any regex stuff. It looks like it does a string replacement here. So let's just run this. Oh, it explains underneath what it does. It always does that. I kind of forget. Yeah, so the tick path. We need the path of the newly built tick program that runs on the build machine so the terminal database can be created without errors, okay? libcurses SO library is needed by a few packages we will build soon. We'll create a symlink to use libcursesw.so as a replacement, okay? The header file Ncurses H is what this said replacement does. The header file Ncurses H contains the definition of various Ncurses data structures with different preprocessor macro definition. Two different sets of data structure definition may be used. The 8-bit definition is compatible with libcurses.so, and the Y character definition is compatible with libcursesw.so. Since we use libcursesw.so as replacement for libcurses.so, edit the header file so we'll always use the Y character data structure definition compatible libcursesw.so. Right, so it's basically just changing the header, so it's including the right bit. Okay. Sorry, it has the correct definition, as to say. Right, now we're going to install Bash. So before we do that, we cd out of here, clear that, and we rmf rfn Ncurses.6.5. Right, and we do next. Right, prepare Bash for compilation. Oh, first thing we need to do, always tart xf. So it's going to be Bash. And then we need a CD into there before we do that. There's nothing to configure because I'm not in the directory. So we need a CD into the directory. Try typing bash rc there, and then we copy and paste this in there. Right, so this is basically the only configure step in there that's new is without bash mallocate. This option turns off the user's bash's memory allocation function, which is known to cause segmentation faults. Well, we don't want that to happen. By turning this option off, Bash will use the mallocate functions from glibc, which are more stable. Right, okay, that's very straightforward. So run the configure step. Then we do make. And then we're going to do the make install. Boom. Right, that looks like that's done. And then make a link for the programs that use the sh4 shell. So this is just a symlink. Symlinks bash. That's how we do that. Right, that looks correct. Okay. My headphones are in the way. And we're going to install Coreutils next. So before we do that, we'll just cd rm-rf Bash, and then, yeah, we're good. Now, again, going to be very mechanical. Ah, right, look. The patch here. It's not telling us to use the patch, I don't think. So let's just read this. The Coreutils package contains the basic utility programs needed by every operating system. Okay. It says nothing about the patches. So prepare Coreutils. So we do the configure step, the meaning of the configure options, enable installed program equals hostname. Enables the hostname binary to build and installed. Is disabled by default, but it is required by the Perl test suite. Okay, so we don't. It doesn't mention those packages anyway, I don't think. And if we see the Coreutils, well, these are temporary tools. Maybe in the when we install the real utilities, what we'll find is that we'll be using these patches. So we do the configure. This is taking a while. Oh, there we go. It's done. We do make. Right, okay. And then we do the make install step. Done. Now, right, it says here, move programs to the final expected location. Although this is not necessary in a temporary environment, we must do so because some programs hard code executable locations. Okay. Right, let's do that then. Right. These look like some man pages. And there's our CH root. And this is doing a substitution of some sort. So we'll just run this. All right. So that seemed to work. There was no issues. CD out this. So before we go, right, I need to be in this sources directory. So we rm -rf Coreutils. Yep. And Diffutils, okay. So we tar xf. This is going to be very repetitive to listen to, I would imagine. Yep. And we do cd diff. And then we configure. There we go. And then we do make. And this will build these Diffutils. I didn't even read what these did. So the Diffutils package contains programs that show the differences between files and directories. Okay, that's what I thought it did. It's just it's a set of Diffutils. And that is installed. So we cd out this, we rm -rf Diffutils. And we do file. The file package contains, well, what does file do? The file package contains a utility for determining the type of a given file or files. So you type file and then typically you type file and then the file name, and it'll tell you information about the file, which is pretty useful. So same process again, start xf, file. And then this one is a little bit different. So let's just read this. Installation of file. The file command on the build host needs to be the same version as the one we are building in order to create the signature file. Run the following commands to make the temporary copy of the file command. Okay. So we do make dir build. We run these configure stat, bzlib, libseccomp, xzlib, and zlib. I'm not sure what that libseccomp is. Should know what it is, but I don't. So we'll just run this. Oh, I messed up. So there's a build directory that should be there. So let's delete that. And I forgot the CD in. Let's try running this all again. I'm just going to run this all as one bit, just to save a little bit of time. Right, so this, right, so the configure step just disables a bunch of things that it's going to be that builds gates. Attempts to use some packages, so the configure script attempts to use some packages from the host distribution if the corresponding library files exist. It may cause compilation failures if the library file exists, but the corresponding header files do not. These options prevent using these unneeded capabilities from the host. Okay. Okay, that's fine. I'm not entirely sure what that. I do know what it means, but I'm not sure if I can explain it well. Right, and now we configure file for compilation. Okay. All right, and we'll do the make step. That looks all good. And then the make install. And then it says remove the libtool archive file because it's harmful for cross compilation. Okay. Oops. I only wanted to select that. Now, we'll see. As for everything, we cd out of here. rm-rf file. There we go. good. And then we'll do Findutils. So what does this do? The Findutils package contains programs to find files. Programs are provided search through all of the files in a directory tree to create, maintain, and search a database, often faster than a recursive find, but unreliable unless the database has been updated recently. Findutils also supplies the Xargs program, which can be used to run a specified command on each file selected by search. Xars is used in a huge amount of scripts, especially ones you find online. So it's a massively useful program. So what we're going to be doing is always the same procedure. So this is Findutils, okay. And we cd into Findutils. There we go. And now we run the configure step. Seems fairly straightforward. And we now type, we compile it with make. Yep. And we now do make install. cd.out and rm-rf Findutils. And we do now build Gawk, GNU. Not sure how you're supposed to say it. Gawk. The Gawk package contains programs for manipulating text files. So let's clear the screen again. tar_xf. There we go. cd. And then we do this. And then prepare to do the configure. It's the same thing again. Right, and then we do make. And then make install. And we're done. And then we're going to do grep. So we're going to cd out of this. Oh, rm-rf. Clear the screen. And the grep package contains programs for searching through the contents of files. Grep is massively useful. I use it all the time. So again, it's tar_xf, grep, cd, grep, make. Oh, configure first, sorry. And then make. And then make install. Ooh, we got a permission denied. Ah. And that's why they tell you to use the LFS user. So I forgot to put the dest in. And what the reason this errors out was it was trying to install this on my local system to USR share. And yeah, this is why. Yeah. So what's happening is permission denied all the way through, and that stopped it from copying over files onto my local, onto the Debian installation that's in the host system, and I would have ended up with a broken system. That's why they make you use the LFS system. That makes sense. So if we do it properly, it works correctly. Okay, that's good. And we now do Gzip, and this is just a compression, decompression program. So before we do that, we do cd out here, rm grep xf gzip cd gzip, and this is, I don't think it's very exciting to watch, but this is quite, this is going to be all very mechanical. Expect then make, and let's try doing this properly this time. I got lazy. All right, that's done. And now we make. The make program contains a program for controlling the generation of executables and other non-source files of a package from the source files of a package from source files. Now, okay. Make is like a task runner, isn't it? Weird explanation. I use make as a task runner for different purposes myself. So their description is a little bit weird. The way I use make is a little bit different. However, what they just, this is a problem with a lot of free software. They use very odd ways of describing stuff. What make does is it runs, it basically automates a set of tasks. And so usually for compilation, but you can use it for all sorts of things. And what this is not necessarily like their description of make it, the way that they describe this is just a bit odd. Essentially, you have when you make a make file, let's just have a quick look at the make file in here. Oops, I was in the wrong window. We do cat make. Oh, sorry, cat make file. Each one of these is a task, and then it runs that. Now, if I did make check local, do that, it'll run like that, and it basically takes a list of files here, and I'm not sure what bin programs is. These are some variables up top, and make all check am. So these are all the tasks that it runs when you type make, and there's phony. I can't remember what phony does. But these are it's just a list of steps. It's just a task runner. So when you do make install, it will basically there's a install somewhere. Yeah, here we go. Make install. It takes wherever the build sources are, and then it does install it goes and runs this with some variables by the looks of it. Install recursive, not great with make files. And it runs install recursive. And if you look down here, there's B in there. Do this. See, there's whatever. Basically there is, take my word for it, there is in there. It's not it's still recursive. There is uninstall. Oh yeah, because it matched to that, I suppose. Okay. Whatever. But that's all make does. When you do make install, it runs a defined set of steps called install. They could be anything really. Usually it's just copying files. So anyway, what we're going to be doing is we're going to be installing make without, on a bit of a tangent there. Get back off that. And then we do gzip. And then we do xf make. We cd make. And then we do the configure. And what does it say? Meaning the new configure options without guile. I just think of the Street Fighter character whenever I see that. Although we are cross-compiling, configure tries to use guile from the build host if it finds it. This makes compilation fail. So we switch. So this switch prevents using it. So it basically just doesn't look for it. Doesn't compile with it, I should say. And then make. And then I don't really need to copy and paste this at the time, but whatever. So that's done. We cd out of here, we rf minus rf make. There we go. And we'll clear the screen and we do patch. And what does the patch package do? The patch package contains a program for modifying or creating files by applying a patch file typically created by the diff program. Okay. So it's tar xf. What's it? Patch. And oh, I need to cd into there first. Then run configure. Right. And then we do make install. Right. So we cd out this rm minus rf patch. So that's it. Basically compiled. It's very straightforward. And then we're doing sed. Sed package contains a stream editor. Yes, sed is the stream editor. Okay, so xf se. Cool. There we go. cd sed. And then we do configure again. And make. I won't lie, I am finding this a little bit tedious. And that is sed made, so rm minus rf sed. Ooh. I did delete it. There's it. Have I? No, it's there. Okay. Got away with that somehow. And now we want to do, see, this is what happens when you start doing stuff. You know, said I was getting a little bit, I find it a little bit tedious. And then I'll start doing stuff quickly, start making mistakes. You need to be concentrating on there. So, yeah, so we've deleted that. And then we're installing tar. And what does tar do? The tar package provides the ability to create tar archives as well as perform various other kinds of archive manipulation. Tar can be used on previously created archives to extract files, to store additional files, or to update or list files which are already stored. Okay. So I think it's like tape archives. If I do man tar. I think originally, yeah. So originally this was like a tape drive. The archive can either be a regular file or device, e.g. a tape file, hence the name of the program, which stands for Tape Archiver. So that's why it's called tar, Tape Archiver. When I first started using Linux, I thought, why is this called off the tar? Because tar is something that you put on the road. you know, tarmac. So I was just like, why is this called tar? But it stands for Tape Archive. And the reason that it was probably, like most of the programs are very short names because back in the day they had very horrible keyboards to type on. That's my understanding. That's what I got told. So we're going to do tar xf tar, and then we cd into tar. Rerun this. Oops. Got to be near the end. We're on X. So I think they're in alphabetical order. And then we do make. And then we do the make install. All right, there we go. And as always, so we cd out here, rm1 rf. Tar. There we go, tar 135. And installation of the xz. The xz package contains programs compressing and decompressing files. So I think it's tar.xz, so you can make archives and compress them with xz, I think. It provides capabilities for the Lisma. It sounds like a euphemism for something else. LZMA and the newer XZ compressor formats. Compressing text file with XZ builds better compressing percentage than with the traditional Gzip or Bzip2, so bunzip, I think that is, commands. So installation of XZ. So we tar xf xz. There we go. cdx xz. They're right. It's right and fumbling my fingers. And we do the configure step. And we do make it's done, and then we do make install. Right, it says remove the libtool archive file because it's harmful for cross compilation. So we did this. I think we did this previously. So maybe you have to do it again. Right, that looks like it's removed. Right, now we're going to install Binutils again. So we'll just read out what it is. I think I read it out in the last video. So Binutils package contains a linker and an assembler and other tools for handling object files. So an object file is, I think, is an intermediate step when building. I think there's object files, definitely C#. When you build a C#, so it sounds like these are intermediate files when you're building. I forget the exact C++, how it builds stuff, but I know that object files are intermediate step, at least in C#, and they're probably C# is kind of similar to. It's basically it's basically like the garbage collected version of C++ that runs in .NET runtime. So they nicked a load of ideas from Java and C++. Well, Java nicked them from C++, all the object-oriented design. Put garbage collecting in there, and the Java virtual machine, C# did something similar with... there's a load of history around this, how Microsoft tried to make their own Java and fork Java, kind of using the old embrace, extend, extinguish model that they always use. Just Microsoft being Microsoft. But that is an aside and not what we're doing at the moment. So before we do this, we need a CD out of here, and we need the rm-rfxz. There we go. Clear screen, and we do tar xf Binutils. There we go. And we CD into Binutils. We'll make the build, and then CD build. Now we run a configure step. Enable shared, build lib BFD as a shared library. Okay. I think that's not what lib BFD is, so we'll just look that up quickly. Binary file descriptor library. Okay. Right, so the binary file descriptor library is the GNU project's main mechanism for the portable manipulation of object files in a variety of formats. Okay, and it supports 50 file formats in 25 instruction set architectures. Okay, that's quite a few. So that's what that does. Let's go back to here. It enables 64-bit support for the binary file descriptor. Okay, so we'll do a configure. And make. Now this took a while last time. Right, I'm back. Just got myself some water. That's quicker than I remember it being. There's some warnings in here, but that looks like it worked correctly. And we did this run, mate, didn't I? Hang on. Oh, yeah. So we do the make install step. Right, and again, we need to remove the libtool archive files because they're harmful for cross-compilation, and remove unnecessary static libraries, okay? So we'll just... do that. So what this does is just remove all these files by the looks of it. It's fine. Yeah, there we go. Okay. So we need a CD out of here. Oh, CD dot dot. There is rm minus f Binutils. Yep. Make sure I'm deleting the right thing. And now what we're going to be doing is we're going to be installing GCC. And this is just a GNU compiler collection, the C and C++ compilers. So let's clear this, trxf, GCC, boom. All right, okay, and we cd into GCC. And I remember doing this last time. So this is basically pass 2. I'm not sure we need a pass 2. But maybe I'll find out later, but I'm not sure why. Well, maybe it tells us in here. Maybe I should read it like I suggest you should do. As in the first build of GCC, the GMP, MPFR, and the MPC packages are required. Unpack the tarbles and move them into the required directories. Okay, so boom, done. Right, if building on x86-64, change the directory name for the 64-bit binaries to lib. Okay, cool. Let's do that. Override the building rules for libgcc and libstdc++ headers to allow building these libraries with POSIX thread support. Okay. Let's just copy that in. Or POSIX. POSIX. So we run that. Create a separate basically it's create a build directory again. Okay, let's do that. For starting to build GCC, remember to unset any environment variables that override the default optimization flags. Now prepare for GCC compilation. Right. We run this. Oh, that was really quick. I don't know what well, I do know what this means. We went over these before in a previous video. Right, so LD flags for target. So what does it say? Is that LD flags for target? And what that means, that environment, that looks like there's some sort of variable that gets set. Well, it's configure option, I'll say. Allows libstd C++ to use libgcc being built in this pass instead of the previous version built in GCC pass 1. The previous version cannot properly support the C++ exception handling because it was built without the libc support. Okay, that's probably why we need to build this again. Disable GCC sanitizer runtime libraries. These are not needed for temporary installation. In GCC pass 1, it was implied by disabled libstd cxx, and now we explicitly pass it. Okay, and then we do make. And I'll imagine this is going to take a while. Right, that's GCC built by the looks of it. So we just need to do make install. Just checking where I was because, to be honest, I made myself a cup of tea. And then we do the make We'll get rid of that. And right, what does it say here? As a finished task, create a utility simulator. Many programs or scripts run CC instead of GCC, which is used to keep programs generic and therefore usable on all kinds of Unix systems where the GNU C compiler is not always installed. So if you was using a BSD, though they typically get GCC. However, maybe if it was on Mac OS, that has its own C compiler, which is part of the Xcode suite. So whenever you use something like Brew, you have to install Xcode via the command line. And then I think that goes and adds its own C compiler and Object-C compiler, I would imagine, if it's Xcode. And that's kind of how it may be. There's other Unix systems such as Solaris, though I think that's kind of dead now. I think there's only Open Solaris, and there's probably other ones. There's probably the HP Unix one, which I totally forgot its name. AIX, HP AIX, another proprietary Unix, and a lot of old Unix systems probably don't use the GCC compiler. So that's what that's talking about. Running CCC leaves the system administrator free to decide which C compiler to install. So let's just do that. That sounds pretty reasonable. Or people might want to use like Clang, which is a newer compiler in the GCC. I've always just used GCC. It's always been easiest. And I think we're going to be up to the next chapter. We click next. But before that, before we do that, CD out and RM-RF GCC. There'll be a lot of gump in there, I would imagine. And then we do next. And we're on chapter 7. So that chapter I didn't find particularly interesting to do. To be honest, I found it very tedious. But obviously it's necessary because we have to install all those temporary tools. It's quite good to... there were some tools that I wasn't aware of. Especially this one, the binary file description, descriptor library. I kind of knew about that, but I wasn't quite sure what it did. So there's a lot of things in there that we had to compile. It was very mechanical. And this is a lot of this stuff is just automated in build scripts whenever they build like a big distro. Because underneath the Linux distro, and any Linux distro, there's a set of build scripts that are basically doing this. They do other things like build RPMs and stuff like that, but whenever this stuff needs to exist for any of these Linux distributions to operate, so every distro is basically doing this somewhere in a build system, and it's all automated because it is a very mechanical process. But that is, we're up to chapter 7 now, and so that's going to be the end of this video, and hopefully see you in the next video. Bye bye.